In face center unit cell, the atoms are present at the corner. Together with the atoms are present at the center of each faces. You know how many faces are there in a cube? There are 6 faces. Then at the center of each faces, one atom will be there, together with one atom in the each corner. Let us represent what I have explained you, that the atoms are present at the corners, each corner. Let us represent the atom at each corner. Clear? We have represent here the atom at each corner. Be careful, I am going to represent the atom at the center of each face. As the name indicates, face center. You know, a cube has 6 faces and atoms are at the center of each faces. Together with the atoms are at the each corner. Let us represent. This one face, one atom here. This one is the another face, upper one atom is here. The backward face, one atom is here. The side face, one atom is here. The downward face, one atom is here. To the next one, the front face, one atom is here. Clear? If you are confused by this figure, then you can assume your room as a cube and then point one atom at each corner. There are 8 atoms. To the next one, place one atom at the center of each faces. We know in a room there are 6 faces. If we placed 6 atoms at the center of each faces, we can see 1, 2, 3, 4, 5, 6 and 8 atoms at the corner. To the next, if we are discussing, let us discuss and the center. Unit cell. Clear? And center unit cell. This is a cube. In case of end-centered unit cell, the atoms are present at the corner of each corner. It means atoms are present at each corner. To the next one, 2 atoms are present at the center of 2 opposite faces. Once more, in face-centered and centered unit cell, the atoms are present at each corner together with 2 atoms at the center of opposite faces. Let us draw it. 1 atom at the each corner, 2, 3, 4, 5, 6, 7, 8. I have represented 8 atoms at the 8 corners. To the next one, 2 atoms at the center of opposite faces. Let us consider one face and opposite face is this one face. I have drawn 1 atom at the center of this face upward and 1 atom at the center of downward face. It means we have discussed the classification of unit cell. It is categorized into primitive unit cell. This is also known as simple cubic. In primitive unit cell, the atoms are present at each corner, as you see here. In center it means atoms are not only present at the corner, they are also at the center. So the next one, centered unit cell. In case it is categorized into three types: body center, face center and hand center. In body centered unit cell, the atoms are present at each corner together with one atom at the center of the body, as you see here. So the next one, in case of first center unit cell, the atoms are present at each corner together with the center of each faces. As you see here, 1, 2, 3, 4, 5, 6. So the next, in case of end-centered unit cell, you can see the atoms are present at each corner together with two atoms are present at the two opposite faces. Clear? Based on the edges, that is A, B and C, and the angle between the edges, that is alpha, beta and gamma. A unit cell is categorized into 7 base type. Remember it, we have discussed. There are 14 Bravarian lattices and 7 basic crystal system based on the nature of the parameter, that is the edges, edge length A, B and C, together with the angle between the edges, that is alpha, beta and gamma. They are categorized into 7 basic crystal system. The first one, we know cubic. As the name implies, cubic, we know in that case all sides are equal and the angle between all the sides is equals to 90 degree. Let us discuss. In case of cubic, A equals to B, it means the side A is equals to B, it is equals to C, and all sides are equal. A equals to B equals to C. And we know the angle between the all side is equals to 90 degree. A alpha equals to beta equals to gamma, which is equals to 90 degree. As in the case we have sodium chloride and zinc blende. It can occur in possible addition, it can occur in BCC, body centered cubic, face centered cubic or primitive. I have explained you what is body center, what is face center and what is primitive. It means the cubic can varied in primitive, body center and face center, in which the edge lengths are A equals to B equals to C and the angle alpha equals to beta equals to gamma, that is equals to 90 degree, and we have a good example of sodium chloride. The next one is zinc blende. To the next, we will discuss triclinic. In case of triclinic, it occurs into primitive, in which all the sides are unequal. Alpha A is not equals to B, not equals to C, and all the angles are not equal. It means alpha is not equals to beta, not equals to gamma, not equals to 90 degree. We have a good example, potassium dichromate. To the next one, the color of copper sulfate pentrahydrate, it is blue in color. It occurs in, it has a triclinic crystal system. To the next one, boric acid S3BO3, it occurs in triclinic system. We will study cubic and triclinic. To the next one, we will discuss tetragonal. It occurs in primitive and body centered. In this case, the sides A equals to B, not equals to C, but all the angles are equal. It is equals to 90 degree. What we have discussed, cubic, all the sides are equal, all the angles are equal, equals to 90 degree. We have the example sodium chloride and zinc blende. So the next one we have discussed tetragonal, in which all the angles are equal, which is equals to 90 degree, whereas one side, that is C, is not equals to B, but B is equals to A. We have the good example, that is calcium sulfate, CaSO4, tin oxide, white tin, titanium oxide. We have an example. To the next one, orthorhombic. In case of orthorhombic, the sides are not equal to each other. That is, A is not equals to B, not equals to C. But all the angles are equal to each other, and that is equals to 90 degree. See here, A is not equals to B, not equals to C. Alpha is equals to beta equals to gamma, that is equals to 90 degree. We have rhombic sulfur, the example of orthorhombic. To the next one, we will discuss hexagonal. In hexagonal, we know graphite occurs in hexagonal sheets. We have example of hexagonal. It occurs in primitive form. A is equals to B, not equals to C, in which one angle is 120 degree, because we know in hexagon one angle is 120 degree, but other two angles are 90 degree. We have the example zinc oxide, graphite, cadmium sulfide. To the next one, rhombohedral or trigonal. It occurs in primitive form, where A equals to B equals to C and alpha equals to beta equals to gamma, but that is not equals to 90 degree. We have the example that side. To the next one, we will discuss monoclinic. It is primitive and center. It occurs in primitive or and center, where sides are not equal, but 2 alpha is equals to gamma. See here, alpha is equals to gamma, not beta. Alpha equals to gamma equals to 90 degree, and beta is not equals to 90 degree. Monoclinic sulfur. Sulfur exists in two forms, monoclinic and orthorhombic. See here, sulfur, and the next one, sulfur. So the next one, triclinic, we have discussed, where all the angles are not equal, which is not equals to 90 degree, and where all sides are not equal. See here, we have the example copper sulfate, potassium dicarbonate, and boric acid. Clear? Let us discuss the type of unit cell and the number of atoms present in each unit cell one by one. But before that, let us know how to represent a unit cell. As I have represented you earlier, that a unit cell can be represented in 3 ways. The first one is open structure. The next one is space filling. And the next one is actual portion. The atom. Let us try to represent them. On open structure, what we do? In open structure, we simply represent the center of unit cell, the center of atom in the unit cell by a point like this. This is open structure. If we want to represent the closed structure, then see here. In order to represent closed structure, we have one atom, two space filling. This is also known as space filling. 2 to the next one, 3 to the next one, 4. Behind that, 4 atoms are also there. This one is 1, this one is 2, and 2 behind this. It means this is known as space filling model, in which we are going to represent the actual size of the atom. Clear? In this way, a cube is represented. I am not able to represent the cube because it is in 3D and the board is 2D. That's why I am unable to represent it. This is open structure, in which we are only going to locate the center of each point or the sphere. In this case, we are not going to represent the actual size of the atom. Whereas in case of space filling model, here we are going to represent the actual size of the atom forming the cube. This is space filling model. This one is open structure. To the next one, actual portion of the atom. In that case, we are only and only going to represent the actual portion of a particular atom in a cube. If we are going to represent it, it is quite difficult to represent. So for that, I am not going to represent it. Clear? Let us discuss the first one, primitive unit cell. We will calculate and we will understand by the open structure. I will draw it. This is primitive unit cell, in which the atoms are only and only present at each corner. Let us discuss what are the number of atoms in primitive unit cell. You know, in primitive unit cell, unit cell, the atoms are only present at the corner of cube. As you see here, if you want to calculate the number of atoms in primitive unit cell, it means the next one is that the number of atoms in primitive unit cell. How we will calculate? Let us discuss. The atom present at the corner. If you assume the atom present in one corner of our room, then you can imagine then that atom present at the corner of the room can be shared by 8 unit cell. How it is so? See here. Suppose this one is the sphere. At the corner. Then it is shared by 1 unit cell here. Clear? If this one is the sphere, suppose this one is the sphere, then one downward quadrant is shared by 1 unit cell. Downward, if we have a sphere and we cut it by the middle one from the center, then we can say it is divided into 2 halves. If we next cut it, it is divided into 8 equal halves. Clear? Then downward one quadrant is shared by 1 unit cell. The next one, the another quadrant by another unit cell. To the behind that one quadrant is there. It will become 3, and behind this one 4. In the same way, we have 4 quadrant in the upper half. What we see? We see that the atom present at the corner. Suppose this one is the sphere. If we cut it from the middle, and the next cut from vertical and horizontal, it is divided into 8 equal parts, and each part, 1 by earth part, is shared by 1 unit cell. It means if we are discussing about this unit cell and 1 atom is present here, then only 1 by earth portion of this atom is shared by this unit cell. Clear? It means the atom present at the corner of the atom share its 1 earth part to the unit cell only. Clear? Let us see. How many atoms are there? 8. It is equals to number of atom in the primitive unit cell is equals to 8. The number of atom is 1, 2, 3, 4, 5, 6, 7, 8. How much portion is contributed by each atom? As we have discussed, only 1 by earth part is contributed by each atom. Clear? And what we see, 1, it is equals to 1 atom. It means if we are discussing the number of atom in primitive unit cell, then we see it contains a total of 1 atom. Why it is so? Because the atom present at the corner of each unit cell, contribute its only and only 1 earth portion. Clear? 1 by 8 plus 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 1 by 8. It is equals to 1 atom. If anybody asks you how many atoms are there in primitive unit cell, then you can answer it contains 1 atom. Clear? Why? Because an atom present at the corner of the unit cell share only and only 1 by earth portion of the atom in that unit cell. It means the actual portion shared by this atom in the unit cell is 1 by earth. How many atoms are there? 8. It is equals to 1 atom. Clear?